Taylor series. If f has derivatives of all orders at x0, then we call the series sigma k is equal to 0 to infinity fk kth derivative at x0 divided by k factorial into x minus x0 the whole raised to k. That's equal to f of x0 plus f dash of x0 into x minus x0 plus f double dash of x0 divided by 2 factorial into x minus x0 the whole square plus etc. The kth derivative of f at s0 divided by k factorial x minus x0 the whole raised to k plus etc. This is called the Taylor series for f about x is equal to 0. In the special case where x0 is equal to 0, this series is called Maclaurin series for f, and it is given by sigma k is equal to 0 to infinity. The kth derivative at x0 is equal to 0 divided by k factorial into x raised to k. So that will be equal to f of 0 plus f dash of 0 plus f double dash of 0 divided by 2 factorial into s square plus etc. fk at 0 divided by k factorial into sk x raised to k plus etc. We can do some problems. For example, find the Maclaurin series for e raised to x, sin x, then cos x, and 1 by 1 minus x. So first one, f of x is equal to e raised to x. Then f double dash of x, f dash of x, and f triple dash of x, etc. So that will be equal to e raised to x. And at x is equal to 0, that what is f of 0 is equal to 1, and f of f dash of 0, f double dash of 0, then f triple dash of 0, etc. So that will be equal to e raised to 0, that will be equal to 1. Thus the Maclaurin series is series for e raised to x is sigma k is equal to 0 to infinity x raised to k divided by k factorial is equal to 1 plus x plus s square divided by 2 factorial plus etc. x raised to k divided by k factorial plus etc. And the second one, let f of x is equal to sin x. Then we can find out what is f of x. So f of x is sin x, then f dash of x is cos x, f double dash of x is equal to minus sin x, f triple dash of x is equal to minus cos x. So therefore f of 0 so is equal to 0, f dash of 0 is equal to 1. So therefore f double dash of 0 is equal to 0, f triple dash of 0 is equal to minus 1. Thus the Maclaurin series for sin x is sigma k is equal to 0 to infinity minus 1 the whole raised to k x raised to 2k plus 1 divided by 2k plus 1 factorial is equal to x minus s cube divided by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial plus etc. minus 1 the whole raised to k into x raised to 2k plus 1 divided by 2k plus 1 factorial plus etc. The next one is f of x is equal to cos x. Then Maclaurin series for cos x. We can the similar way we can find out what is the Maclaurin series for f of x is equal to cos x. So we will get sigma k is equal to 0 to infinity minus 1 the whole raised to k x raised to 2k divided by 2k factorial. That's equal to 1 minus s square divided by 2 factorial plus x raised to 4 divided by 4 factorial minus x raised to 6 by 6 factorial plus etc. minus 1 the whole raised to k x raised to 2k divided by 2k factorial plus etc. Now next one is f of x is equal to 1 by 1 minus x. The values of f and its first k derivatives at x is equal to 0 are f of x is equal to 1 by 1 minus x. Therefore f of 0 we can find out that's equal to 1. So that is we can write it as 0 factorial. Then f dash of x is equal to 1 by 1 minus x the whole square. Therefore f dash of 0 is equal to 1. So that you can write it as 1 factorial. F double dash of x is equal to 2 divided by 1 minus x the whole cube. Then f double dash of 0 is equal to 2. That you can write as 2 factorial. Then f3 dash of x is equal to 3 into 2 divided by 1 minus x the whole raised to 4. Then f3 of f3 dash of 0, so that will be equal to 3 factorial plus etc. The kth derivative at x of f is equal to k factorial divided by 1 minus x the whole raised to k plus 1. Therefore, kth derivative of f at x is equal to 0, so that will be equal to k factorial. Thus, the Maclaurin series for 1 by 1 minus x is sigma k is equal to 0 to infinity x raised to k is equal to 1 plus x plus s square plus etc. plus x raised to k plus etc. Next example, find the Taylor series for 1 by x about x is equal to 1. So we can take f of x is equal to 1 by x, then f of 1 is equal to 1, f dash of 1. So you will get minus 1, f double dash of 1 is equal to 2 factorial, f 3 dash of 1 is equal to minus 3 factorial plus etc. Then f kth derivative of f at x is equal to 1. So that will be equal to minus 1 the whole raised to k into k factorial. Thus, the Taylor series for 1 by x about x is equal to 1 is sigma k is equal to 0 to infinity minus 1 the whole raised to k into x minus 1 the whole raised to k. So that's equal to 1 minus x minus 1 plus x minus 1 the whole square minus x minus 1 the whole cube plus etc. plus minus 1 the whole raised to k, x minus 1 the whole raised to k plus etc. Now we can find out what is a binomial series. If m is a real number, then the Maclaurin series for 1 plus x the whole raised to m is called a binomial series, and it is given by 1 plus mx plus m into m minus 1 divided by 2 factorial into s square plus m into m minus 1 into m minus 2 divided by 3 factorial into s cube plus etc. plus m into m minus 1 etc. m minus 1 k plus 1 divided by k factorial into x raised to k plus etc. We can see some examples. Find the binomial series for 1 by 1 plus x the whole square and 1 by root 1 plus x. So first one, using the formula 1. So this is the formula 1. Substituting m is equal to minus 2, we get 1 by 1 plus x the whole raised to whole square is equal to 1 plus x the whole raised to minus 2. So we can apply this result, this formula. So that's equal to 1 plus, here m is equal to minus 2. So 1 plus minus 2 into x plus minus 2 into minus 3 divided by 2 factorial into s square plus minus 2 minus 3 into minus 4 divided by 3 factorial into s cube plus etc. So that you can simplify, and we will get 1 minus 2x plus 3 factorial by 2 factorial into s square minus 4 factorial divided by 3 factorial into s cube plus etc. You will get 1 minus 2x plus 3s square minus 4s cube plus 5x raised to 4 plus etc. That's equal to sigma k is equal to 0 to infinity minus 1 the whole raised to k plus 1 into x raised to k. So that is a binomial required binomial series. Then second one, substitute m is equal to minus 1 by 2. So in the above equation for binomial series, we get 1 by root 1 plus x is equal to 1 minus 1 by 2 x plus minus 1 by 2 into minus 1 by 2 minus 1 divided by 2 factorial into s square plus minus 1 by 2 minus 1 by 2 minus 1 into minus 1 by 2 minus 2 divided by 3 factorial times x cube plus etc. That's equal to 1 minus 1 by 2x plus 1 in 1 times 3 divided by 2 square times 2 factorial times x square minus 1 times 3 times 5 divided by 2 cube into 3 factorial into s cube plus etc. So that's equal to, we can write in sigma notation, 1 plus sigma k is equal to 1 to infinity minus 1 the whole raised to k into 1 into 3 into 5 etc. 2k minus 1 divided by 2 raised to k into k factorial into x raised to k. Now we can see the different Maclaurin series and the interval of convergence. So that is 1 minus x, in general case 1 minus x, then 1 plus 1 divided by 1 plus s square is equal to 1 minus s square plus x raised to 4 minus x raised to 6, then e raised to x, then sin x, so and cos x, then log 1 plus x, then tan inverse x. We can find the interval of convergence is minus 1 less than or equal to x less than or equal to 1. In sin hx, the hyperbolic function sin hx, so that will be equal to x plus s cube divided by 3 factorial plus x raised to 5 by 5 factorial plus x raised to 7 by 7 factorial plus etc. So their interval of convergence is minus infinity less than x less than plus infinity. Then cos hx is equal to 1 plus s square divided by 2 factorial plus x raised to 4 by 4 factorial plus x raised to 6 by 6 factorial plus etc. The interval of convergence is minus infinity less than x less than infinity, and 1 plus x the whole raised to m is equal to 1 plus sigma m is equal to k is equal to 1 to infinity m into m minus 1 into etc. m minus k plus 1 divided by k factorial into x raised to k. So the interval of convergence is minus 1 less than x less than 1, where m is not equal to 0, 1, 2, 3, etc.